Okay, thank you. So I'd first like to position this work a bit. Like what I see, so I'm from a design department, so I have a kind of a different catch on user experience methods. So what I see is at least the use of quantitative methods is very much done at the end of a project to kind of validate what is happening. So what I'm trying to say, and then when you worry about whether people interpret the same question in the same way. So what I'm looking at much more is to use quantitative methods as a way to explore the design space and actually embrace diversity rather than being afraid of it. Although we did, so this is actually a follow-up of a paper from 10 years ago that was done together with Evangelos Karapanos, a PhD of mine at that time, and also with Mark Hausensal. And so that's more or less the topic that I was just introducing. So if you want to read more about the argumentation for it, it's there. But we also created a problem saying that, okay, if we allow people to answer in their own way, judge in their own way a number of products, how are we going to manage that diversity? So we created a problem. We had a kind of a hands-on solution, but not a very good one. And so it took me about a year to develop an automated algorithm, but I never got around to publishing it. So it turns out like the 10th anniversary seemed like a good opportunity to try. And so I'm not a fast mover in this way. So I will start by, so what I'll be talking about is how you use quantitative data and visualize that back to the people who might have generated it and start maybe a discussion and to create design ideas from that. So it's not an assessment tool, although you probably could also use it for that purpose, but it's certainly not primarily intended as an assessment tool. And I'll start with a kind of a textbook example where everything works fine, just to see what you could do, and then move on to the example that we introduced 10 years ago in the paper and showed how we at least propose to handle this now. So the key message will be, as is in the slide, is that if I have a complex problem, I cannot visualize this in 2D. So I might have to use 4D, 5D, 6D to visualize this, which obviously nobody can do. So the key take-home message of this is, okay, why not just stick to 2D views? If there's nothing else that we can look at, maybe also 1D views. And so the solution will be not to have one view, but multiple views, which you would have to do anyhow if you look at any 3D object and you want to see the different sides of it, you have to take different views on it. So that's the take-home message, so you already know what we're heading for. This was a study of one of our students, Daphne Menere, one of the IDEA students, and a typical way of using this. So she was interested in sports bracelets something like 5 years ago, or even longer. As I said, I'm a slow publisher. And she was taking the products which were on the market at that time. And you see 3 examples of that. And she was wondering, trying to see, and she picked 8 representative products out of the market. And she was wondering, basically, is the design space covered with this, or are there interesting opportunities for designing within this space? And she used a method that probably a lot of you know is a repertory grid technique, and it's just to say that I'm going to create diversity. So I probably don't need to explain, but basically I'm asking for personal constructs from a number of products, a number of participants, by giving them triads of products and asking them to come up with their own constructs. So I'm not using a standard usability questionnaire or anything else, although in the past sometimes we mix these personal constructs with standard constructs if you want to have a combination of the two. So these were the 9 constructs that participants came up with, and then we did a somewhat larger questionnaire asking online, asking a number of people to rate these, how much their disagreement or agreement with these statements like, okay, this this bracelet is luxurious, is a piece of jewelry or whatever. Do you disagree or agree with that? And so if you want to see more about the example, you can find it online. And this is what you get. Very nice to look at, but not very informative. So what we know how to do is look at one item at a time, so we can analyze, for instance, not only taking means, but also confidence intervals to get an idea about are there any real differences between these bracelets. And the best and the worst one in terms of judgment about jewelry is shown in this picture. The problem is we don't understand relationships because we're looking at one item at a time. So if you want to look at multiple items at a time, you probably want to use something like clustering. But the easiest thing to do is to look, in this case, at 1D clusters, and you find that there are actually 2 clusters. So a number of these constructs behave very similarly in terms of the answers that people give. But it's still not very informative trying to understand if there are any opportunities for designing something. By the way, so whatever I'm talking about, the algorithm, it's available within a public software system that I'm distributing. So if you want to try something out on your own data, it's possible. And so this is the visualization that we're generating for that example. So the red and the blue clusters are what were considered to be the one-dimensional clusters. And you can see if you do this in 2D, you already get an idea that even maybe the 1D clustering is a bit off. And so what you're trying to see in the right graph, you're trying to show on the one hand the projections of the points. The points represent the different bracelets, and the arrows represent the different constructs. And so what makes it a textbook example is in the paper we also describe a way to characterize whether the model is actually a good fit to the data, an adequate fit to the data, or a poor fit to the data. So these terms will come back. But why is a textbook example is that everything fits well in this case. So nothing wrong, and it fits well in 2D. And so how did the student use this in the design project? He says, for instance, okay, if I look at all the bracelets that are in there, I see something very weird. I see that sportive is just opposite to feminine. So I could get a lot of people in the audience angry if I really believe that. What it says is that in the existing design space, that seems to be the case. So that's what you're looking for. I think say things that actually look like they are nonsense in a visualization like that. Because you say, okay, there should be ways to break out of this design space and design something that doesn't have that relationship. So to show what she eventually designed, this is the bracelet that she designed as an output of her project. Okay, back to the data that we had 10 years ago. It was data generated by Mark Hasenzahl and one of his students. It was as a trial for the repertory grid technique, one of the first studies done with the repertory grid technique. They had a number of German websites that they were comparing, and they asked university students and also candidate students to rate this, and they allowed them to use their own constructs. So I'm just going through just to give you a feeling about how these websites look like, not that you have to. And so they used the repertory grid technique, asked people to elicit their own constructs. And people came up with a diversity of constructs. Some had to do with the graphical layout, some had to do with whether they looked playful or professional, some and others. There were also constructs that only one person, for instance, came up with in order to also embrace the diversity. He says, do I get the feeling that the university supports, you could say, offline activities or free, activities which are not university activities? So the problem you get is you get a table like that doesn't fit on my screen. It's like I have 8 websites and I have 118 constructs that I don't actually know what they mean because people made them up themselves. So there's something like, and people can do this, they came up to 10 to 14 constructs by themselves. And so these are some of the... So what's the problem that we identified? If you look at, and you just give this to a clustering algorithm, and you ask, okay, make me a 2D rendering of it, it turns out that it does not just average out over everything. No, it turns out it does a good job for some attributes and allows a job for all the rest. So what it would mean is that if you do this in 2D, you get a representation for 20 of the 180 attributes. So that means that you put a lot of effort into querying all these subjects, and then you say, well, I throw away your results because they don't fit into anything that I can visualize. And so visualizing for me is a 2D graph. And if I want to get everything in, I have to go to a high dimension, but then I can't view it anymore. Or at least I will have to make 2D projections of that high dimensional space, which requires interaction to do it, or whatever. It's random. I'm not sure that I'm taking the right views. So could we come up with an algorithm that came up with as much diversity as possible in the views? It turned out that after some researching, there was an algorithm in SAS statistical package called VARCLUS that does that for 1D patterns. So we had to extend that to 2D. It's an interesting case where nobody knows anymore who the original author is. So there's actually some papers, but they always say, well, we don't know actually who invented this. One of the key graphs is this one. So if you started doing that, there's one parameter that you can control that controls how many views you're generating. So I'm just increasing this. I'm just trying to look at how many, and on the bottom left you have the point where I said if I take only one 2D view, I got a representation for 20 attributes. And what you see, surprisingly enough, this keeps going up almost linearly, up to 10 views. I can maybe also get round with 6 views if I look at the sum of good and adequate fit, so it's your own decision. I think in the end, what I did in the paper, I settled on the in-between on 8 views. Another way of looking at the same data is that I still keep a very flat, if I look at the average number of attributes that are being covered per view. So these are some of the things that are generated. So if I run the algorithm, I get 8 of these. Now you say, okay, I'll come back to whether does this help me or not. But I get 8 of this. What you see is that I see bold arrows to say, okay, these fit well. These actually have a good fit. I have just regular sized arrows to say that's an adequate fit. And it even shows all the dotted arrows are the ones that are actually not in this view, that are being positioned in another view. So they're in another cluster. This was from the original paper. That means that how do we relate, what is the model for an answer on an attribute? It's just a projection on different axes. So for people who have a problem how to interpret these kind of figures. So the first question, obviously also put by the reviewers when I submitted this paper, saying, okay, in which sense does this help us? Is it actually, should we be happy that we have 10 views instead of just 1 or 2? And my answer would be yes, because it is a rich perspective. Because otherwise you are literally throwing away some of the perspective that some of your users have actually offered to them. For instance, if you did this, you would have lost the one single user saying that, oh, does my university support activities in free time, or does it only support curriculum activities? So that might have been lost. But on the other hand, I do think you need some kind of procedure how to handle this. And so that's what I'm proposing in the paper, is saying that but it's just a way how you could handle this, so maybe people can come up with other alternatives. Saying that, well, I just picked one of the attributes that I find interesting, so I picked out one of the items that people said, it's a modern layout, which can guide me to the view that this attribute has been assigned to. Which is, so I say, and then I can ask 2 questions. If I look at this view, which happened to be the same one as I was showing you before, but now with mentioning what these different attributes are, is I could say the people who were doing this study were actually S1 at the bottom there, at the university website S1, so which was the one at the bottom left there from Darmstadt. And you can see that the website that scored much higher on modern layout was the one from the University of Munich, which is all the way up there. So one way of looking at these graphs is what I would call evolutionary design. Say, what could I do to move my website or wherever in that space? So I would take examples. That's why I would call it evolutionary. Say, if I want to have a much more modern layout, I would look at 7 and 8 and see what they are doing differently from me. But what is even more interesting is, and also the way the student was using it in my first example, is he say, if I'm considering revolutionary design, saying that there's some relationships in that graph, like A5 and A67. So easy connection to the university is opposite to a modern layout. That's, again, obviously in general a nonsense statement. But that seems to be in the space of the designs that are available. So would you be able to make a design for which this opposite does not hold? So it could actually, so as I said, I'm not offering a final solution. It's not an assessment tool. It's a way to reflect what you've observed. If I have a little more time, I can, okay.
I'm sorry. We have to leave time for questions. So
okay.
Thank you.
No problem. I
can give you 30
the next thing you can do with it.
I can give you 30 seconds on it if you want to summarize it quickly.
I won't even try.
Okay. Thank you. So, questions? John.
If you go back to the graph you just showed, it looks like scientifically oriented and technically oriented are opposite. Seems like nonsense, at least from your...
Well, I had to do two things because the original study was done in German, so I had to use my best German to translate. And obviously, sometimes the constructs are a sentence. And I had to, but I think was mostly, well, that's an issue always. What were the users intending when they were saying that? What they were comparing, because some of them were technical universities, some were general universities. And they clearly reflected that. So I think they were mostly related to that. So, well, that's the 30 seconds what I would have said now.
Okay.
So in this case, the way I was presenting it here, the researcher has to interpret this. What would really be interesting, what I can't do anymore, of course, would if you made these views and also related them back to the people who made them, and I can even condense it, that's the second part, it's about personal constructs, first derive personal constructs, and then only show those, which is fewer than 118. But it's trying to say what would happen if we use these visualizations, so if we're using it as a design tool to see if that would structure help the discussion. And at least it would help, for instance, like everybody's filled in the questionnaire, so at least the opinions of everybody are already on the board. So somebody should be responsible for the judgment that he makes. So maybe not only the people who speak up the loudest actually have an influence, but it would also be a way to make the discussion maybe even more democratic. But I'm speculating, as we haven't done that.
Other questions? Comment on that question. I wonder if scientifically oriented might be related to the domain rather than the technical aspects of the system.
Well, the data doesn't. I'm using the data as I got them from Mark, so I don't know all the. Because then you would have to interview, but that's exactly where it becomes interesting.
It wasn't actually a question; it was just a speculation.
Yeah.
So anyway, more questions? We need the mic, please. Over here.
It looks like VARCLUS is really similar to biplots. So you reduce the dimensionality of the data, and then you try to explain this reduced dimensionality space by using those axes. But the axes really introduce a lot of error in the visualization. So have you accounted for that? Have you seen where, for example, the scientifically and technically oriented, maybe there's an error of the visualization and not there in the data?
Well, so it's not similar to biplot. That's why it took me a year to figure out the algorithm. It's a very iterative thing because it really looks to find clusters where things match best and to assign everybody. So it's a very iterative algorithm. So every time you do a clustering and then you reassign the attributes to clusters, you see if they fit better in another cluster. So it's a really exhaustive search that you do. So it's not a linear system. What you are saying is these people agree on how the stimuli relate to each other. Mm-hmm. So they relate that some are similar and some are different. And what you're reflecting in that figure is saying, what wording do they actually use to kind of explain that? So I'm not looking into validity. I'm much more interested if this inspires new ideas. And for new ideas, for me, is especially maybe moving in that space, but even more interesting, figuring out something looking abstractly at the things that don't seem to match. And why is that the case? And how can we break out of that design space? Because any design space has some implicit assumptions in it. So it's trying to bring the implicit assumptions out in an explicit way.
Thanks.
Okay, thank you.